Deep inside your tissues, a microscopic security force is constantly scanning for threats. When a pathogen enters, your body sounds a biological alarm, sending white blood cells swarming the invaders to neutralize the danger. That immediate, localized response is acute inflammation, a functional, short-term mechanism designed to repair wounds. However, when this alarm system fails to deactivate, the response becomes chronic, causing immune cells to begin degrading healthy tissues and organs over years or decades. This 3D schematic isolates the NF-κB pathway. It functions as the biochemical interface governing your inflammatory genes, forming a physical bridge directly into the cell nucleus. Stress hormones, metabolic data, and immune responses all converge directly onto this pathway. Systemic inflammation is a biomechanical state dictated by these specific biological inputs. Mapping our daily vectors, diet, movement, and stress, and environmental exposure allows us to modulate this pathway and regulate the inflammatory response. Before adjusting those inputs, you must establish a diagnostic baseline to determine the current intensity of the inflammatory response. The Wellness Wheel assessment facilitates this by requiring you to rate your physical and emotional health on a scale from 1 to 5, plotting specific areas of deficiency. Scaling these metrics reveals hidden systemic signs of chronic inflammation. Persistent fatigue and constant brain fog serve as direct physical markers that your body is locked in an inflammatory loop. Chronic inflammation is a quantifiable state of cellular error. Mapping symptoms to their underlying biochemical triggers is the mandatory first step to regulating the NF-κB pathway. Food acts as the primary chemical input, modulating the NF-κB system daily. Every meal provides a set of instructions that either upregulate or suppress inflammatory gene expression. Ultra-processed foods, refined carbohydrates, and trans fats break down rapidly during digestion, causing an immediate, aggressive spike in blood sugar levels. This spike forces an emergency response, where cells triggered by metabolic overload immediately activate inflammatory gene expression. The structure of dietary fats dictates a similar response. This model compares the jagged, volatile structure of omega-6 fatty acids found in refined seed oils, which spark inflammatory signals, against the stable structure of omega-3 fatty acids found in cold water fish. Specific micronutrients such as zinc and vitamin C and D, along with plant polyphenols like curcumin, act as pharmacological agents. Here, they are neutralizing and dismantling damaging free radicals before those radicals can trigger the NF-κB alarm. The pantry purge protocol applies this chemistry by swapping a high-sugar item for a whole food, high-fiber alternative. Replacing sugary cereal with oatmeal and dark berries changes the chemical data provided to your cells. Curcumin, the active compound in turmeric, provides potent anti-inflammatory effects. Adding a sprinkle of black pepper to the recipe chemically optimizes the body's ability to absorb this compound. Dietary management provides the exact biochemical inputs required to neutralize oxidative stress at the cellular level. Physical movement offers a separate mechanism of chemical control. Dense skeletal muscle fibers contracting under strain reveal a hidden pharmacological function. Skeletal muscle operates as an active endocrine organ. It manufactures and secretes chemical messengers directly into the bloodstream the moment it contracts. These messengers are called myokines. Physical exertion causes muscles to release specific proteins, irisin, IL-6, and BDNF, into general circulation. Once in the bloodstream, these myokines regulate the immune system by docking onto macrophages and natural killer cells, cooling their activity and clearing out residual inflammation. Maximizing this effect requires a combination of aerobic endurance training and resistance weightlifting to ensure complete muscle fiber recruitment and combat metabolic disease. The Myokine Minute Protocol triggers this process. 10 minutes of brisk walking combined with light resistance, like squats or push-ups, forces an acute release of these proteins. Exercise functions as a pharmacological intervention, turning skeletal muscle into a pharmacy that manufactures anti-inflammatory proteins. Psychological stress initiates a physical cascade of chemicals through the brain-body connection. This schematic illustrates the hypothalamic-pituitary-adrenal axis. The HPA axis serves as the brain's first responder to psychological stress, transmitting signals directly from the brain to the adrenal glands. Sleep deprivation and chronic stress trap this circuit in a feedback loop. The resulting overproduction of cortisol correlates with a sharp spike in the inflammatory marker IL-6. Chronically elevated cortisol suppresses normal immune function and triggers widespread systemic inflammation, overriding the body's natural healing capacity. The nervous system must be downregulated to stop this cascade. This can be achieved through adaptogenic herbs like ashwagandha or through active mindfulness and nature exposure. The protocol for sensory-focused downregulation utilizes 5 minutes of mindful breathing to mechanically slow the heart rate and depress the secretion of stress hormones. Psychological exhaustion forces the physical manifestation of tissue-damaging chemical cascades until the nervous system is downregulated. Invisible environmental chemicals bypass our behavioral defenses, interacting with our cells to disrupt our biological baseline. These endocrine-disrupting chemicals, or EDCs, include bisphenol A and phthalates, which are prevalent in plastics, personal care products, and canned foods. The harm is structural. EDC molecules mimic the shape of natural hormones, allowing them to hijack the cellular communication system by locking into the site designed for biological signals. This binding generates intense oxidative stress and disrupts immune tolerance, forcing the cell to activate its inflammatory signaling pathways to respond to the chemical intrusion. The Plastic Patrol protocol reduces this exposure. Replacing a single plastic food container with glass or stainless steel removes a primary source of these disruptive chemicals. Because EDCs activate the same signaling pathways as metabolic stress, these pollutants can force the inflammatory engine to remain active even when diet and exercise are optimized. Managing the NF-kappa B pathway is an act of comprehensive biological engineering. Optimizing systemic health requires simultaneous control over 4 inputs: diet, myokine release, HPA regulation, and toxin avoidance. Biological knowledge remains inert without a sustainable system for behavioral execution. SMART goals provide the mechanical tool for this transition, making objectives specific, measurable, attainable, relevant, and time-bound turns health aspirations into executed tasks. Maintaining self-efficacy requires a supportive community and the establishment of peer accountability loops. Drafting a personalized wellness blueprint involves creating 3 specific SMART goals, such as consuming high-fiber legumes twice per week or maintaining an 8-hour sleep schedule. Sharing this blueprint with a peer locks in the accountability loop necessary to sustain these habits. Actively managing your environmental and internal inputs provides actionable clarity, replacing overwhelming health anxiety with lasting physiological control. Lowering chronic inflammation is an act of daily biological engineering, driven by the specific inputs within your control.